If you could dig a hole straight through the Earth, what would you find? Lava? Solid rock? Something even more incredible?
Have you ever wondered what's really under your feet? I mean, not just dirt and rocks, but what's thousands of kilometers deep? Well, today, we're going to go on an incredible journey to the center of the Earth, a place no human has ever been. So let's get started. So let's just kick things off with a huge question. Imagine for a second you had a super shovel, one that could dig through literally anything. If you started digging straight down and just didn't stop, what would you actually find along the way? We're talking about a journey of over 12,000 kilometers through some seriously unimaginable heat and pressure. Well, the first thing you'd find out is that Earth isn't just one big solid ball of rock. Nope. As you can see here, it's actually made of different layers. You can think of it like a giant jawbreaker, or maybe even a peach. You've got the thin skin, then the fleshy middle part, and finally that hard pit right in the center. And we're going to explore every single one of them. Okay, our first stop on this adventure is the layer we know best. It's the one we live on, build on, and grow our food on. This is the Earth's crust. And while it might seem totally massive to us, you're about to find out that on a planetary scale, it's basically just a paper-thin shell. So, what is the crust? Simply put, it's the solid, rocky surface of our planet. That's it. Everything we see around us, all the mountains, the valleys, the oceans, the continents, it's all part of this incredibly thin outer layer. This is our home base for the entire expedition. To really get your head around just how thin it is, try this. If the Earth were the size of an apple, the entire crust, all the mountains, continents, and the deep seafloors would be even thinner than the skin of that apple. It's this incredibly fragile layer just kind of floating on top of some really powerful forces below. And here's something cool. This crust isn't all the same. There are actually two types. You've got the continental crust, which is the thick stuff that makes up all of our land. But then, underneath the oceans, there's a much thinner but heavier oceanic crust. It's kind of like a thick, fluffy piece of bread for the continents and a thin, dense cracker for the seafloor. Okay, hold on tight because we've just punched through the crust. We are now sinking into the biggest layer of them all. Welcome to the mantle, a huge, superheated zone that makes up most of our planet. This is where the real action begins. Now, the mantle is weird. It's not exactly solid rock, but it's not liquid magma either. It's in this strange in-between state, a semi-solid rock that's so hot it can actually bend and flow over millions of years, almost like a ridiculously thick, slow-moving glob of plastic. Just look at this. The mantle makes up a staggering 82.5% of the Earth's total volume. That's insane. The crust we just left behind and the core we're heading towards, they're tiny in comparison. This right here is the true engine room of our planet. So, how does this almost solid layer actually move? Well, imagine a giant pot of super thick honey. The heat coming up from the core way down below makes it churn in super slow motion. And these powerful currents are what literally drag the tectonic plates of the crust around, shifting entire continents and causing earthquakes. All right, we've traveled nearly 3,000 kilometers down, and the conditions are getting extreme. The pressure is absolutely crushing, and the heat is just unbelievable. We are arriving at the very heart of our planet, the super hot metal core. And just like the crust, the core isn't one simple thing. It's actually made of two very different parts. First, we have to pass through a swirling ocean of liquid metal, which we call the outer core. And then, right at the very center, we'll find a solid ball of metal, the inner core. Let this sink in for a minute. 5,000 degrees Celsius. That is unbelievably hot. For a little perspective, the surface of the sun is around 5,500 degrees. So yeah, the center of our planet is literally as hot as the surface of a star. So why is a liquid metal core so important? Well, as this ocean of molten iron swirls and churns, it acts like a giant dynamo, creating Earth's massive magnetic field. This is the invisible force field that protects our entire planet, you, me, everything, from harmful radiation from space. Without it, life as we know it just couldn't exist. And finally, we've reached it, the very center, the inner core. Now, even though it's hotter than the outer core, the pressure from all those layers above is so immense that it crushes the iron into a solid. This solid metal ball is huge, roughly the same size as our moon. And get this, scientists think it's actually spinning slightly faster than the rest of the planet. A spinning world, inside our world. Okay, journey complete. But hold on. If we can't actually dig to the center of the Earth, how on earth do we know all of this stuff? How have we mapped out a world that we can never, ever visit? Let's find out. This is the big question, right? We can't send a camera down there. We can't take a sample. So how did scientists figure out that there's a liquid part and a solid part? The answer is brilliantly clever. The answer is in earthquakes. See, when an earthquake happens, it sends out these powerful vibrations called seismic waves that travel all the way through the planet. Scientists can listen to these waves on the other side of the world, and by studying how they change on their journey, they can map the interior. It's like giving the planet a giant X-ray. It works just like this. An earthquake generates waves. Those waves travel through all the different layers, the crust, the mantle, the core, and each time a wave passes into a new layer, it either speeds up, slows down, or bends, just like light going through a prism. By measuring all those little changes, we can piece together a map of the inside of the Earth. And here's the smoking gun. There's a specific type of seismic wave, it's called an S wave, that physically cannot travel through liquid. And scientists noticed that these waves never make it through the center of the Earth. They create this massive shadow on the other side of the planet. That shadow is the undeniable proof that the outer core must be liquid. And just to put our limits into perspective, this is the deepest hole humanity has ever managed to dig. Over 12 kilometers straight down. I mean, it's an incredible achievement, but it barely scratches the surface. It's just 0.2% of the way to the center. So, yeah, that's why we need those clever seismic waves. All right, before we finish our journey, let's do a quick rapid-fire round of the most amazing facts we've uncovered deep inside our planet. So let's run through it. We have the thin crust we live on, then the massive flowing rock of the mantle, then the liquid outer core that creates our magnetic shield, and finally the solid inner core. Don't forget that our crust is basically floating on the mantle. And for a final mind-bending mystery, scientists are now finding clues that suggest there might be an innermost inner core, a tiny, distinct metal ball right at the very heart of our planet.
So, you see, our planet is so much more than a solid, boring ball of rock. It has a complex and fiery heart that literally makes life on the surface possible. Our journey is over, but it really leaves you wondering, doesn't it? What other incredible secrets are still locked away, just waiting to be discovered deep inside our world?
If you enjoyed this video, please like, share, subscribe, and hit the bell so you never miss a new lesson.